Now that we know the quadratic formula, the only way that these get a little more difficult is if they don't equal 0 ahead of time. So remember, when we're solving quadratic equations, we need them to be in the form ax squared plus bx plus c equals 0. If we don't have that equals 0, we're not ready to use the quadratic formula. We don't necessarily know our a, b, and c until we get it in that form. So this first example has two different sides of the equation. It's not equal to 0. I would always suggest keeping x squared positive, or if x squared isn't positive, moving it to the other side. So we're going to move terms to the other side of the equation. And ideally, we want x squared to be positive. With x squared positive. It still works when x squared is negative. This is more just my personal preference, and seeing that it is sometimes easier, there's less negatives to deal with if we keep x squared positive. So what that means for this problem is that I'm going to add 2x and add 3 to both sides of the equation. All right, we are still solving an equation. So as long as I do the same to both sides, totally allowed to do that. So what I get then is x squared plus 2x plus 3 equals 0. And that's exactly what we wanted, is that equals 0. As soon as we have equals 0, now we can read off what our a, b, and c are. In this case, this one's pretty nice. It's just a is 1, b is 2, and c is 3. So now we're ready to use our quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Get that memorized if you haven't already. Opposite of b is negative 2. And notice I'm not using the b from the original problem. We had to get it into that equals 0. So now we know b is positive. Plus or minus the square root of b squared. Do that in your head. 2 squared is 4. Minus 4 times 1 times 3 for 4ac, all over 2 times 1. Okay, next step is to simplify what's under the square root. You can use a calculator or not. This one's not too difficult, but I still want to check. 4 minus 4 times 1 times 3 equals. And I get negative 8. So this is negative 2 plus or minus the square root of negative 8 all over 2. Next step is to simplify what's under the square root. So if this were a perfect square, we would take the square root. If it's not a perfect square, we look for perfect squares that go into it. The other thing that you may have already noticed is that this is a negative under the square root. That means that we're going to have I in our answer, that it's going to be an imaginary number or complex number for our solution. So what I'm going to do is think of the square root of negative 8, and I'm just going to write out everything else. Negative 2 in the top, positive 2 in the bottom. But instead of the square root of negative 8, I'm going to think about it as just the square root of negative 1, then the square root of 4, and the square root of 2. I'm sorry, I'm off the screen a little bit there. Great. The reason I'm pulling out the 4 is because it's a perfect square, right? It's the perfect square that goes into 8. The 2 is just what's left over after I pull out the negative and pull out the perfect square. Because negative 1 times 4 times 2 makes negative 8. So this lets me simplify. Negative 2 plus or minus. Then we get 2i times the square root of 2 over 2. Now I flipped the order here. Instead of I times 2, I made it 2i. The order doesn't matter. Really, the I could go after the square root, and that's probably even, I don't know, better mathematical notation. Doesn't really matter. But to simplify this is when we get to use our heart simplification. That we look for what goes into all 3 of these pieces, which in this case is 2. So I need to divide all 3 terms by 2 to simplify this fraction. And really, because they all end up with ones, the simplest form of this is just -1 plus or minus the square root of 2 times I. So my two solutions are -1 plus square root of 2 times I and -1 minus the square root of 2 times I. So in this problem, there are no real solutions. But we found two complex solutions because we ended up with the square root of a negative in our work. Let's do this last example. Make sure we're all getting it here. This one, we got some work to do ahead of time. And the work we have to do is FOIL. We have to multiply this all out. We have to deal with this 2 on the outside. So I think what I'm going to do is multiply the 2 with the first set of parentheses, do this distribution before I do FOIL. You could just as easily do it afterwards. If FOIL's not your thing, you can use the box method. I know some of us have really liked that. We just need to multiply this out, however you best do that. So I'm just going to use FOIL. First is 2x times 3x, that's 6x squared. 2x times -1 is -2x. 2 times 3x is plus 6x. And then 2 times -1 is -2. Right. So FOILed. Already we're starting to see this is an ax squared plus bx kind of situation. Couple things we need to do though. One is that we have some like terms to combine in the middle, but the other is that I don't have equals 0 yet. We have to have equals 0 in order to use the quadratic formula. So what this simplifies to, once we get it equals 0 and we combine the like terms, 6x squared plus 4x minus 3. And the minus 3 came from the -2 I got from FOIL, and then -1 from getting the 1 to the other side. So now, separate that one. So now I know my A is 6, my B is 4, and my C is -3. So that I can use the quadratic formula. X equals the opposite of B plus or minus the square root of B squared. Do it in your head. 4 squared is 16 minus 4 times 6 times -3 all over 2a. If you're simplifying the radicand without a calculator, make sure you see that a negative times a negative makes this a positive. This should not end up with a negative under the square root. But I'm going to use my calculator just to double check, make sure I'm doing it right. So I'm just doing what's inside the square root. Let's clear that out. 16 minus 4 times 6 times 3, make it negative, equals. So what I get from this is -4 plus or minus the square root of 88 all over 16. Now that we have it mostly simplified, we have to simplify the square root part of it. So we look for perfect squares that go into 88. Now I know for sure that 4 goes into 88, but maybe something bigger than 4 does. Like, does 16 go into 88? Almost. It's got decimal though, so that doesn't work. So let's just do 88 divided by 4. 22 is 2 times 11. Neither of those are perfect squares. So when simplifying square roots, I only care about perfect squares. Like 4 and 16 and 25. 22 doesn't have any of those in there. So this is how we're going to simplify it. And what I get once I do the square root of 4 is -4 plus or minus 2 square root of 22 all over 16. To make this fully simplified, we're going to use a little heart and look at what goes into all 3 of those terms. And it is a 2, so I'm going to divide all 3 by 2. Get -2 plus or minus the square root of 22 all over 8. So our solution set for this problem is -2 plus square root of 22 over 8 and -2 minus square root of 22 over 8. Since these are real numbers, you could, sorry, I didn't realize I was off screen there. Since these are real numbers, you could use your calculator and get a decimal. Maybe I'll go ahead and do that just to make sure. And then once you get a decimal, you could check to see if it really does make the original equation true. So let's try this. So 2 negative plus 22 square root equals. So when getting a decimal, you just do the top of the fraction first, 2.69, and then divide it by 8. So I got 0.336-ish. The other one, make it 2 negative minus 22 square root equals. So I'm just doing the top of the fraction. I get negative 6.69, and then I divide by 8. And that's approximately negative 0.836. So if we were checking our solutions, we could plug in those two decimals in the original equation to verify that our exact solutions are accurate.